Hello everyone, welcome back to our last Ed puzzle. I believe this is our last Ed puzzle for this motion unit. This is part 4. We did motion in one dimension going horizontally, then we did motion in one dimension going vertically with free fall, and now we're in two dimensions, which is going to be going horizontally and vertically. It's going in both directions. So this will be fun. We're going to be launching some rockets soon and doing some calculations with that. And I don't think this math is particularly much harder than the other stuff we've been working on. So it's just kind of putting the pieces together. So the first thing you need to know is that a vector in two dimensions can be broken up into components. And we want to break them up into an x component and a y component. So here's a picture of a boat, and the boat's in the river, and the boat is sailing in this direction here. However, it is moving in that direction, but really the engine of the boat is pushing it up, and the river is pushing it right. So there's two components to the direction of the vector of the boat. There's the vertical component, which is the v of the boat, which is going north, and then there's the east component of the river going to the east. Also keep in mind, they put them on the left and the top, but it could easily be written on the right and the bottom. You could put, this could be v river, and this could also be v boat on this side, and it would be the same size in the same direction. It would be the same vector. This would basically be a rectangle, right? So if you have a rectangle, the bottom is the same size as the top, and you could see our v river is the same size and the same direction, so it's the same vector. We're really going to be calling these. We're going to be calling these. Really Vx and Vy. So these vectors are going to have a horizontal component, which is our Vx, and a vertical component for our Vy. And so to calculate these, we can use some trig. So if we know the magnitude and the magnitude and direction of the vector, we can break it up using trig. So you should know this already. You should know that sine is the opposite over the hypotenuse. So for this angle here, it would be equal to this side divided by the hypotenuse. So what I mean by that is, let me back up. Let me put some numbers here. Let's say this is 20 degrees, and this side is 6. And this side is 10, then you would have sine of 20. Actually, I'll write it up here. So you would have sine of 20 equals opposite. The opposite side is the 6, and the hypotenuse is 10. Okay. Cosine is the adjacent over the hypotenuse, which is our x part. So it's basically going to be the same thing. It will just be the adjacent over the hypotenuse. Let's do an example. I think it'll make more sense when we have an example. So a rocket is launched at 60 meters per second at a 60-degree angle. And we want to find the horizontal and vertical components. So I'm going to draw a picture like always. This is my velocity at 60 meters per second, and it's at a 60-degree angle. Okay, and we want to find the horizontal component and the vertical component, Vy and Vx. Okay, those two, Vx and Vy, make up our velocity. So I'm going to use sine first. So sine of my angle is opposite over hypotenuse, SOHCAHTOA. So that means sine of 60 equals opposite. The opposite side is my Vy over the hypotenuse, which is 60. So how can I solve for Vy? I'm going to cross multiply, and I would get Vy is 60 times sine of 60. Sine of 60 is 51.96. So I get 60 times 51.96. So I get Vy is put it in my calculator. Oops, that's not right. Oh wait, no, sorry. Let me back up. I tried to get this a little ahead of time and I messed up. Let's back up. So it's going to be 60, and then sine of 60 is 0.866. So then you get Vy is 60 times 0.866, which is what I had at the beginning, 51.96. Okay, so that's one of my answers. So that would be this side right here. So I know this side is 51.96. This is my Vy. So to find Vx, I'm going to use cosine. So cosine of 60 is adjacent over hypotenuse. So adjacent is the side next to it. So it's this side, which is my Vx. And my hypotenuse is 60. So I'm going to do the exact same thing. I'm going to cross multiply, and I get Vx equals 60 times cosine of 60. And so Vx would be 60 times 0.5, which is 30. Okay, so that means this side is 30. So you're basically getting the x part and the y part that make up the vector. So just like our boat, where the boat's path, this path is made up of this side plus this side. It's made up of the x component and the y component. So I'm just breaking it apart. So for ours, I'm breaking it apart and I'm finding what the x component and the y component are equal to. All right, last slide. I would like you to try this one. This is going to be for some points. So get it right, get the points right. Miss it, you're going to miss some points. You should be able to get this. So draw a picture, do just like we just did. Give me what a Vx equals and a Vy equals. Go for it. Give it a shot. Awesome job, everyone. We'll go over this in class, and then we're going to apply it to some more things. And looking forward to it. I'll see you guys soon.